For the past year, an artificial intelligence AI war between OpenAI, Microsoft, Google, and others has supercharged the disruptive field, each competing head to head and releasing new and more powerful models. While Google was not first on the AI scene, it now intends to rise to the top with Gemini speculated as the most powerful AI model ever to exist. Gemini was launched on Wednesday, December 6, 2023, so we will now see how the long game plays out. This is how Gemini works, how powerful it is, and what it will be able to do. It is everything we know about Gemini in this video. Let's watch Gemini introduction by Google and Alphabet CEO.
One of the reasons we got interested in AI from the very beginning is that we always viewed our mission as a timeless mission. It's to organize the world's information and make it universally accessible and useful. But as information has grown in scale and complexity, the problem has gotten harder. So we always knew we needed to have a deeper breakthrough to make progress.
I've worked on AI my whole life because I've always felt it would be the most beneficial and consequential technology for humanity. Human beings in our society would have 5 senses, and the world we've built and the media we consume is in those different modalities. So I'm super proud and excited to announce the launch of the Gemini era, a first step towards a truly universal AI model.
The Gemini approach to multimodality is all the kinds of things you want an artificial intelligence system to be able to do. And these are capabilities that haven't really existed in computers before.
Traditionally, multimodal models are created by stitching together text-only, vision-only, and audio-only models in a suboptimal way at a secondary stage. Gemini is the multimodal from the ground up, so it can seamlessly have a conversation across modalities and give you the best possible response.
Gemini is our largest and most capable model. It means that Gemini can understand the world around us in the way that we do and absorb any type of input and output. So not just text like most models, but also code, audio, image, and video. What's amazing about Gemini is that it's so good at so many things. As we started getting to the end of the training, we started seeing that Gemini was better than any other model out there on these very, very important benchmarks. For example, each of the 50 different subject areas that we tested on, it's as good as the best expert humans in those areas.
It's very rare that you can work on a technology at a foundational level and it simultaneously can impact all our products.
We created a family of models that can run on everything from mobile devices to data centers, each of which is actually best in class.
Gemini will be available in 3 sizes. Gemini Ultra, our most capable and largest model for highly complex tasks. Gemini Pro, our best performing model for a broad range of tasks. And Gemini Nano, our most efficient model for on-device tasks.
We want to provide the best foundational building blocks, and then we know developers and enterprise customers are going to figure out really creative ways to further refine our Gemini foundational models, and the potential's almost limitless.
So at Google, there's this healthy disregard for the impossible, and that has oriented us to be both bold and responsible together. As these systems become more capable, all of those capabilities also raise new questions.
We have to think about what it means to have an image be a part of, for example, the input. Because an image might be innocuous on its own, or text might be innocuous on its own, but the combination could be offensive or hurtful.
Safety and responsibility has to be built in from the beginning. And at Google DeepMind, that's what we've done with Gemini.
We develop proactive policies and adapt those to the unique considerations of multimodal capabilities. We then do rigorous testing against those policies to prevent the harms that we've identified with approaches like classifiers and filters.
If I were to look at the foundational breakthroughs in AI over the past decade, Google has been at the forefront of many of those breakthroughs. And I think Gemini continues that rich tradition.
It's been an enormous sort of monumental engineering task, which has been, very challenging, but also very exciting.
I have been at Google for quite a while, and the reason I'm here is really I believe in the company's mission, and I think Gemini is a great step in that overall mission.
We end up with a world that has more knowledge and that people have more access to information that otherwise would not be available to them.
That's what excites me, the chance to make AI helpful for everyone, everywhere in the world.
As per Google, they have been rigorously testing their Gemini models and evaluating their performance on a wide variety of tasks. From natural image, audio, and video understanding to mathematical reasoning, Gemini Ultra's performance exceeds current state-of-the-art results on 30 of the 32 widely used academic benchmarks used in large language model LLM research and development. With a score of 98%, Gemini Ultra is the first model to outperform human experts on MMLU massive multitask language understanding, which uses a combination of 57 subjects such as math, physics, history, law, medicine, and ethics for testing both world knowledge and problem-solving abilities. Gemini Ultra also achieves a state-of-the-art score of 59.4% on the new MMNU benchmark, which consists of multimodal tasks spanning different domains requiring deliberate reasoning. With the image benchmarks we tested, Gemini Ultra outperformed previous state-of-the-art models without assistance from optical character recognition OCR systems that extract text from images for further processing. These benchmarks highlight Gemini's native multimodality and indicate early signs of Gemini's more complex reasoning abilities.
A common problem scientists face is the need to find and use data extracted from the scientific literature. This is difficult because scientists need to search among thousands of scientific papers for key information and extract them by hand. It's a very common workflow and very time-consuming. In fact, some of our scientists at Google DeepMind face this very problem. They use Gemini to help with it because Gemini has an incredible understanding of science. Taylor will explain more.
So we were looking at this study from 2022. The authors had created a data set by reviewing tens of thousands of scientific papers in genetics. They found a few hundred papers that contained the relevant information, extracted it by hand, and collected it in a table. Studies like this can take a lot of time. We needed to update this data set with what's new over the last couple of years. But that's over 200,000 new open access papers added to this domain since 2021. We couldn't do this manually, so we asked Gemini to help us out. First, we needed to filter for relevant scientific papers. We wrote a prompt, just like this one, telling Gemini exactly what to look for. With its advanced reasoning capabilities, Gemini was able to distinguish between papers that were relevant to the study and those that weren't. For the relevant papers, we wrote a similar prompt, asking Gemini to read the paper and extract the key data for us. We could even ask Gemini to add annotations. This showed us exactly where in the paper Gemini found the information. We ran this at scale. And over a lunch break, Gemini read 200,000 papers for us, filtered it down to 250, and extracted their data. So now we have a refreshed version of this data set. But because Gemini is multimodal, not only can it reason about information from text, it can also reason about figures. So let me show you something really neat. With our refreshed data set, we can now ask Gemini to update a graph from the original study. We first gave Gemini a screenshot of this figure. Then we asked it to generate the code required to plot it. And by feeding this code our new data set, we get our updated figure. You can see that this figure now includes data up until 2023.
So Taylor used Gemini to search a large corpus of literature for relevant papers and extract key information from these papers, as well as update figures. Of course, these capabilities can help more than just biologists or even scientists. They extend naturally to any domain that is reliant on large datasets, such as law or finance. So that's what Gemini can make possible, and we are excited to see what you will create with Gemini.
As a parent, you may have to help your kid with their homework. I've certainly had to. Here's where Gemini can help. For this demo, we've created a simple interface, and with some clever prompting under the hood, we can really leverage Gemini's math, reasoning, and multimodal capabilities to learn a subject like physics. With Gemini, you can upload a photo of handwritten answers on a worksheet. Not only can Gemini solve these problems, but this is the amazing part. It can read the answers and understand what was right and what was wrong, and explain the concepts that need more clarification. So Gemini identified some mistakes with problems 1 and 3 here. Let's take a look at 3. Here, Gemini identifies that the formula was correct, but there was a mistake in calculating height. We can ask Gemini to explain in more details why the height is 50 meters instead of 6. I can ask Gemini to explain further. Here, Gemini explains the step-by-step details to solving the problem. Because of Gemini's ability to understand nuanced information and answer questions relating to complicated topics, it can give you a customized explanation of the subject you're trying to learn. And lastly, if you want to learn more, you can just ask. Gemini will provide personalized practice problems based on mistakes. Here I have a similar problem where I have to figure out the cat's speed, where the height of the ramp is double. Oh yeah, I knew that.
We built Gemini from the ground up to be natively multimodal, including something quite important for both of us, programming code. Gemini is able to consistently understand, explain, and generate code that is correct and well-written in most programming languages. That includes Python, Java, C++, and Go. It substantially improves coding abilities over previous PaLM 2 models. From a benchmark around 200 programming functions in Python, it consistently solves about 75% of them in the first try, versus around 45% on PaLM 2. If you allow Gemini to check and repair its own answers, this number jumps to over 90%, which is a huge step forward. It can help you create and prototype new ideas in seconds. Let's give it a try. I really like trains. And if I wanted to create a train spotting location web app, I can simply ask and get a working prototype in less than a minute. While the code isn't perfect, it's really helpful to have a first draft. Gemini on its own has the ability to transform software development as we understand it, but it can also be deployed as a key component of more sophisticated systems.
Gemini is great at coding, but we've been able to take it even further, creating a specialized version that performs remarkably well at competitive programming. Now, why do we care about competitive programming? Well, it is one of the ultimate litmus tests of algorithmic coding abilities. So you have thousands of talented programmers from all over the world that come together to compete and try to solve incredibly complex problems that require not only coding, but also math and reasoning. 2 years ago, we presented AlphaCode, and it was the first AI system that could compete roughly at the level of the average human competitor. Today, I'm delighted to introduce AlphaCode 2, a new and enhanced system with massively improved performance, powered by Gemini. When we evaluate AlphaCode 2 on the same platform as the original AlphaCode, we solve almost twice as many problems. While AlphaCode broke through the top half of human competitors, on average, we estimate that AlphaCode 2 performs better than 85% of competition participants. Let's have a look at our model in action on one of the hardest problems that we faced. And I say hard because in the original contest, in which the problem appeared, less than 0.2% of participants actually solved it. The problem is quite difficult, it's very abstract, so I can't get into too many details, but the basic gist of it is that we are tasked with computing aggregate statistics that account for what appears to be an impossibly large amount of random arrays. The really cool thing is that to solve it, AlphaCode 2 makes use of dynamic programming. Dynamic programming is an advanced algorithmic technique which basically simplifies a complicated problem by breaking it down into easier subproblems again and again. And what's really impressive is that not only AlphaCode 2 knows how to properly implement this strategy, but also when and where to use it. What the example shows us is that competitive programming is not just about implementation. It's also about understanding, maths, computer science, and indeed coding. And that makes it an extremely hard reasoning task. So it's not very surprising that up till now, generally available large language models have scored very poorly on this benchmark. These models are really, really good at following instructions, but AlphaCode needs to do more than that. It needs to show some level of understanding, some level of reasoning, designing of code solutions before it can actually get to the actual implementation to solve the problem. And it does all that on problems that it's never seen before. Another thing that is great about Alpha Code is that it performs even better when it collaborates with human coders who can provide grounding. Basically, developers can specify properties that the code samples have to obey. And when we do that, we see performance increase significantly. We think of this kind of interaction between programmers and AIs as the future of programming, where coders will not just give instructions, but actually collaborate with highly capable AI models that can reason about their problems, that can propose code designs, and that can even help with the actual implementation. AlphaCode 2 was built for competitive programming, but we're already working on bringing some of its unique capabilities right into the general Gemini models as a first step towards making this new programming paradigm available for everyone.
Google only put Gemini Ultra up against GPT-4. That means we don't know how well Gemini Pro and Nano can compete with GPT-4. Thanks for watching this video. I hope you enjoyed this video.